Hello, and welcome back to Tomato Tomato. I am your host, as always, Talia Sherman, and get ready for my interview with Professor Ellie Pavlick from Brown University. For the first time in the history of this podcast, I interviewed a computer scientist and computational linguist. Professor Pavlick holds a BA from Johns Hopkins in economics and a PhD from UPenn in computer and information science. And now, she not only teaches CS and linguistics at Brown, she's also a research scientist at Google AI. So, all this is to say that Professor Pavlick is probably one of the most impressive people I've ever had the privilege to speak with. We're going to talk about linguistics and computer science and what the two have to do with each other. So we're going to be talking about natural language processing, linguistically conscious AI, pre-trained models, and of course, ChatGPT. We're also going to touch on how pre-trained models inherit the biases of humans and how complicated it is to mitigate those biases. I was so honored to interview Professor Pavlick. She has so much research going on, and it's all very timely and very prescient to the future of linguistics, computer science, and cognitive science. So pay attention, jot down some notes if need be. Maybe you're going to have to look up a couple keywords like neural nets if you don't know what those already are. But get ready for a very quantitative, yet very, very entertaining episode with the absolute genius of a human, Professor Ellie Pavlick. Welcome to the podcast, Professor Ellie Pavlick. It is great to talk to you.
Thank you. Yeah, it's great to be here.
Yeah, so aside from your sort of academic credentials, could you tell everyone what you're interested in, passionate about, what you do research on, what you teach, and why it's important?
Yeah, for sure. So broadly, I work on natural language processing, which I feel like, as a field used to be somewhat obscure and is now like major news, right? With the success of the kinds of models we have. So I guess natural language processing, broadly speaking, is we're trying to build systems, computational systems that can basically use and understand and work with language, ideally, as well as humans, right? That's kind of the dream. How close we are is still a big open question, right? So I guess the work I'm currently doing, I'm very excited about. I mean, everyone in my field, not everyone, but the field in general is very excited about deep learning and neural network models. And we've had huge successes with these types of models. So people have probably been reading about GPT and ChatGPT and these kinds of models that can talk to humans and seem human-like, right? And the work that my lab is really interested in, and I've got very excited about, is trying to understand really how those models are working and how legitimate it is to draw comparisons between them and what humans do. Because the truth is, we really don't know how they work, like why they work. We know, some basic low-level stuff about how to make deep learning systems train, but we don't really understand why the models that we're building have the impressive properties that they do. And we also don't know, there's a lot we don't know about how humans work. And so trying to draw a comparison is really challenging, right? We have to figure out more about how the computers are doing what they're doing, and we have to try to figure out more about how humans are doing what they're doing, and then try to figure out whether those are analogous processes, right?
Interesting. So can you just briefly explain what deep learning in computer science means, as opposed to sort of the colloquial definition?
Absolutely, yes. Yeah, so deep learning is a type of machine learning, and it's particularly one, the reason it's been so, people are so excited about it is it's one that takes very minimal, what we would call feature engineering in NLP. So traditionally in natural language processing, or when we would build computer models to understand language, and this was the case when you think about computational linguistics. So it used to have a lot more linguistics involved. Like people would say, if we want this computer to do a good job translating from English into French, we need to know about the grammar of French. We need to know about the grammar of English. We need to write down rules that describe those processes. And then we have to maybe define, like we'll need a dictionary that maps words to words, but we'll also need a mapping between the grammars. And there might be all of these kind of important kind of structured pieces of linguistic knowledge that would get built into a system, and then they would be operated on to perform well. In deep learning, there's actually none of that. It's basically, we're just going to put in a ton of data and let the system, quote unquote, figure it out. And so when this kind of machine learning came around, people were very excited about the idea of this idea that maybe models could learn a ton of structure from scratch. They could learn what matters from scratch, and we don't have to tell it that. And that this was kind of seen as progress, because it's like, maybe there's a lot of things we don't know, but maybe the system can figure it out for us. That's gotten a lot of pushback, I think, recently, because sometimes it succeeds and we have these great successes, but there's also a lot of people from linguistics and cognitive science who are like, hey, there is a lot of things we do know about how humans work. It's one, dumb to reinvent it. And also it's possible that the system won't figure it out. And then we're actually going to handicap ourselves by not giving the machine access to stuff we know about how language works that it could use. So I would say, broadly speaking, deep learning is it's a type of machine learning that basically doesn't take as input any of that kind of structure. And that's both been very exciting to people to see how well it can do with such minimal input. And also maybe a source of frustration or a source of debate between people who have different opinions about how we should be studying these things.
Okay, so since there's sort of this debate, but it also seems like it is progress to have to be able to sort of like train a model to like learn a lot from scratch, right? I mean, you've talked a lot about the disparity between understanding language form and understanding language meaning. Like NLP models don't know the difference really between syntax and semantics, and they're learning a lot of language from scratch, but there's this disparity between meaning and form. So why does that disparity exist? And what is the problem with that, I guess?
Yeah, so that is very much something that is, like I said, still kind of being debated. So I guess I should say, so for these models, these deep learning models that are getting very impressive progress, the way they're trained is basically on this test called language modeling, which is predict the next word in a sentence. So you just have the model guess what the first word of a sentence is. It makes a guess. It says the, and you say, yep, good job. It was the, like, predict the next word. And it says dog. And you're like, nope, it was actually cat. And it's like, okay, noted, right? And you say, okay, the words are the cat. What comes next? And it says slept. And you're like, good job. It was slept, right? And it just does that for a very, very, very large amount of data. And that's really all they're being trained to do. So the fact that then you get this really impressive ability to answer questions and translate between languages and engage in random chit chat and tell jokes and write poetry, right? Like it's quite incredible that they can do all of that. But there's been a lot of pushback to the fact that we can even make claims about whether they have, quote, meaning, because they've never had access to anything other than sequences of words, and they're always trying to predict the next word in a sentence. From the machine's perspective, these might as well be arbitrary symbols, right? Rather than saying the cat slept, it could be like green blob, blue spiky thing, and yellow slash marks. Like they could just be like any random things that it's just sliding around these little tiles and trying to figure out patterns between particular tiles, right? And so there's a lot of people in the field are saying that this means that the model can't understand meaning. It doesn't know what a cat is. It doesn't know what sleeping is, but it can understand form, where form is like it knows what makes a grammatical or plausible sentence. And this is, I think, like Chomsky has this distinction very clearly, like colorless green ideas sleep furiously, right?
Yeah.
Really good example of good form, nonsense, completely no meaning, right? And so there's, like, linguistics has always known there's this distinction between form and meaning. But I think what NLP is challenging a bit on this is where actually is that line and what is the distinction? So, and I think it could probably advance the studies of this quite a bit, right? So the models not only generate grammatical sentences, but they also generate plausible ones. And the plausibility of a sentence is very much constrained by meaning. So they're never going to say colorless green ideas sleep furiously, because that's just not something it will have ever seen. I'll just learn those words don't go together. So in the same way that it'll produce stuff that's grammatical in terms of form, it also tends to produce stuff that is meaningful, like that we can interpret as meaningful, right? And that can be confusing. So people aren't really sure to what extent that means it does capture meaning, or if it just fundamentally does not capture meaning by virtue of never having had access to anything other than language. I think this is like I said, a very active, very interesting debate. I used to feel very strongly that the model, without access to something other than text, it couldn't have meaning. I still, like, in my gut, feel that way. It feels wrong to say the model understands meaning if it's only ever read words. But the more I think about it, the more I consider different theories about what meaning representations look like in humans' heads, I can see a valid argument for how you can say maybe the models, sure, they don't have perception, but that doesn't mean they don't have meaning, because a lot of how we understand meaning is by relating concepts to other concepts. And so I think basically there's a valid argument to be made on either side, whether they have meaning or don't have meaning. And it's something that I haven't come down with a decision on yet, I think. But there's there's interesting arguments to be made on either side, I would say.
Okay, interesting. So it's still in progress. That's good to know.
Yeah, I think it's very much in progress. I mean, because I would say, I think in formal semantics too, it's interesting to make the connection to formal semantics, right? Because a lot of the arguments about language models not having good meaning representations come from the fact that they like don't have perception. But kind of the program of formal semantics is that is this kind of representation that's divorced from the particulars of how it would ground, right? So you would say, oh, I'm going to have this like abstract meaning representation that kind of helps me relate, like helps me reason about entailment, for example, but I don't need to ground it out in the truth conditions to know that something is entailed. And I think a similar argument could be made for language models. You could say, yes, it doesn't know the truth conditions, but it does know how the truth conditions relate, right? And that's, so this notion of abstraction, I think it is worth really thinking rigorously, and it would be exciting to have more linguists really thinking rigorously about how we should think about these language models, because either they're like a complete offense to the formal semantics program, or they're a really nice example of it, right? And we're not quite sure which one they are.
Interesting. So can you give us an example for people who don't know, like what the formal semantics program and sort of entailment?
Yeah, so a classic, there's like I forget whose quote it is, but there's a quote of like knowing, knowing the meaning of I have a bag of potatoes in my cupboard doesn't require knowing whether I have a bag of potatoes in my cupboard, right? Like there's like you have some abstract representation of it that kind of tells you what has to be true in the world in order for that to be true. And most of semantics doesn't specify that function that would actually allow you to determine, right? Formal semantics is not in the business of describing what light waves need to hit your retina in what particular way for you to verify that this is true. More, it's saying, if this is true, what else must be true? And then making sure we have representations that guarantee that if I say I have potatoes in my cupboard, it means there is something in my cupboard, right? And making sure that my representation of the sentence, there are potatoes in my cupboard, is intrinsically connected to my representation of the sentence, there is something in my cupboard, such that I can't assert that there are potatoes in my cupboard without also asserting that there is something in my cupboard, right? And that would be like the entailment relation. Now, of course, language models look nothing like this, and they really don't obey these kinds of conditions. But the people, you can make an argument that they could, right? That there could be something about the representations that would allow them to reason about entailment or something in this way. And it really doesn't depend on having perception or being able to go and check whether there are potatoes in the cupboard. So I think in that way, the kind of notion of grounding and the need for, or the lack of need for it, there's almost some strange bedfellows between the neural network language models and formal semantics in that way, to say like what we really care about is reasoning of these abstractions that are abstractions over perception or whatever.
Right. Like, if you say I have a bag of potatoes in my cupboard, it entails that you have a cupboard. So is it kind of like where, if you give this model a sentence that is completely false, like historically perhaps, like, oh, I don't know, Mike Pence is president. Whether it knows that's false or true, it entails that Mike Pence is the 47th president or something like that.
Exactly. Yep. Exactly. Because like what we really care about in semantics and linguistics is not describing the world as it is, right? Like that's like almost an artifact of what one can do if they have language. But most of what we care about in language is talking about how language works and how language relates to other language, such that when I say something, you can make inferences about what is and isn't true based on what I say or what I do and don't believe, right? Like it's really about the connection between language and, of course, the connection between language and the world. But again, that connection between language and the world is like a constraint on how formal semantics behaves, right? It's not actually a part of what is done in formal semantics. And we really do like to deal with this abstract level of meaning.
Along with like correlations and your research at Google, which I think is really impressive. So I was going through all your publications, and something that's really stood out to me was this one called Measuring and Reducing Gendered Correlations in Pre-trained Models. And you talk about sort of the unintended associations encoded in these models, like, the word surgeon being associated with male pronouns more than female pronouns. So how does sexism work in pre-trained models? How does racism work in pre-trained models? How does a pre-trained model learn to make these correlations and non-helpful associations? I, in preparation for this interview, talked to one of my friends who studies computer science, And he's sort of talking about how like it can be that it's just like data being sexist, that there are perhaps more male surgeons, or it can be that humans like make these models to be sexist or problematic. So what are the implications of this bias? What's going on here? How do we stop it? What's happening? Yeah.
Yeah, right. Yeah, it's interesting because so you ask like, how do they learn this? And I think I always think of the question is like, how wouldn't they
Right.
learn? Like,
Yeah.
in many ways, like the way the models are now, there's almost no way they're not going to encode this, and without us putting in significant effort to prevent it. And part of it, I think what your friend says is true. I think that the former is much more prevalent, is the data they have is biased, right? So again, we're looking at or we're talking about these language models. All they do is, given some words, predict the next word. And if most of the text on the internet that talks about surgeons mentions men and male pronouns, the model, if it's doing a good job, it's definitely going to assume that the correct pronoun is he or she, or he or his or him, right? Just because that's statistically much more likely given its training data, and all we've asked it to do is be really, really good at reproducing its training data. So it would just be bizarre for the models not to encode this bias when we give them biased data. And the truth is, most of the data is biased, right? The world is such that more men are surgeons. And perhaps even if it's trended better recently, I think for surgery it probably still is mostly male, although I think for physicians as a whole it's more female. But if the text on the internet, if more of the things that people have written are about male surgeons, maybe they get more news articles written about them, maybe they're just historically has been more prominent, whatever it is. If there's just more likelihood of the word surgeon being followed by male pronouns, right, the model's going to encode that. It's not like somebody built the model and went in and said like, let's add this bit here, like the sexism feature, and just turn that on, right? Like it's not like a really intentional thing, but it is just, if it's in the data, the model's going to encode it. And then the problem is it's really hard to turn it off or to change it because of the way the models are built, right? So they're, like I said, they don't have these features the way traditional machine learning did. So everything they know is encoded kind of implicitly in this soup of neural net space, right? So neural nets are learning a really, really they're basically solving a very large number of equations. They have big matrices that they're multiplying all of them together. And somewhere in these billions of cells of matrices is the information about the relationship between surgeons and gender. And we don't know exactly which numbers encode that. And it's probably smeared over millions of them, right? So it's not like we can go in and flip a bit or turn off some feature and change the behavior. We don't actually know where in the model the information is represented. And even if we can kind of find it roughly, we don't know how to like ablate it out without destroying a lot of the other properties of, like, basically without rendering the model somewhat useless, right? So we're really in our very early stages of understanding how the models work, which makes it quite hard to fix them. There are workarounds, and that's the kind of thing we were working on in that paper. Like there are kind of various tricks you can use. One of them is basically trying to generate fake data, or otherwise imagine the world is such that it's better balanced. If you do something like that, you can get the model, like if the model trains on data that has as many female doctors as male doctors, it has no reason to think that doctors are going to be male. There's some challenges with doing it. Like if you generate fake data, the data can like look artificial, and the model might just learn to treat it different in practice. There's like kind of some various reasons with that. And there's also this kind of whack-a-mole problem that you have to know what biases to remove and then go remove them. Like there's no way to kind of just tell the model, hey, don't be sexist, hey, don't be racist, right? Like you can't do it in this all-purpose way. Instead, you have to find every instance where it might have this problem. You have to do it for doctors, and then for nurses, and then for teachers, and then for secretaries, and then for presidents, and then for CEOs, and you have to do it for every single one, right? And that's just really not feasible. So I think right now, again, we're really in very early stages of understanding enough about how the models will work that we can go in and fix it in a really clean, systematic, reliable way. A lot of progress has been made, but we're not quite at the point that we can flip a switch and be like, hey, stop being racist, right?
Okay. So it's kind of like the human mind in that sense.
I think very much.
It takes like you can't flip a switch. Yeah.
Exactly. And I think that that analogy is one I make a lot, not because I think that the neural nets are basically a human mind, but our level of understanding that is analogous, right? Like we know humans do all of these things and we see their behavior that suggests they do those things, but we don't know where it is. Like no one could go in and do a brain surgery in order to suddenly make you like, you know, happier or less racist or better at math. Like we don't know how to do that. And we also don't know how to do it in the neural nets.
It's very important to me to ask everyone who I interview why they're doing the work that they're doing and why linguistics matters in the work that they're doing. And so I think with you being majoritively a computer scientist and teaching in the CS department at Brown and doing all this research at Google, what is interesting and fascinating and crucial about bringing linguistics into your work? And how will it benefit everyone? How would anyone benefit from understanding a bit more about linguistics and CS and their intersection?
Yeah, that's a good question. I think that like I think of myself as much a linguist or cognitive scientist now as a computer scientist, and largely this is because of the types of questions we're trying to answer right now about the models. So in computer science, the training you get is how to build stuff, right? Like there's a lot of theory, like how to prove stuff about the things that you build, but the types of things you're proving is like, you know, computer sciencey stuff, not language stuff. And you learn how to write code and you learn how to write the code in a way that's clean and efficient and easy to change and yada, yada, yada. But what people don't learn how to do in computer science is how to generate theories about a system and then test those theories, like generate hypotheses, come up with models, and come up with descriptive analysis of how a system is working, right? And that is actually all of what linguistics and cognitive science is, right? It's about coming up with a theory and a model that describes human behavior, human language, like tells like what are the rules that determine whether a person will or will not produce a certain sentence, right? And just the scientific program that you do in those disciplines, I think is exactly what computer science needs right now, because we don't understand how the systems work. And linguists have tools for generating theories and then testing those theories about a system. And traditionally the system they've been analyzing as humans, but now we can analyze neural networks, and doing that kind of thing helps us learn how those systems work. So I think that just the scientific discipline of linguistics and cognitive science is like actually a very helpful way of approaching computer science right now. I think it's super important. Like I think these systems are becoming incredibly pervasive. So just like in a practical level, we really need to understand how they work, right? Like it's scary to think about having widespread use of technology that we don't really understand, right? I know this kind of thing does, you know, happen. Like there are a lot of medicines that we do this, for example, right? It's like we don't really know why this thing helps with depression, but it does, so we are prescribing it. But it's a weird thing, right? It's a weird thing to think about. And of course, we're always trying to understand how they work. For something like AI, it just feels like something that there's high risk to deploying it and having it help people make decisions, helping people write everything from news articles to resumes to text messages to their friends or whatever, like without really understanding how it's getting from point A to point B. So I think that this is where linguistics and cognitive science actually has the toolkits for figuring out how they work, whereas computer science doesn't always have those toolkits. I guess I'm purely scientific curiosity, which is my main motivation, is just it's so cool to think about building a system that actually can do language the way humans do, right? Like that's just like a holy grail of AI, I think. So most of my interest in the connection between humans and human studies of language and humans and the study of language and machines is purely just because it's so interesting, like that, without any practical purpose. But I think there's very practical reasons too that make it actually very important and timely.
Yeah, but like, okay, so like with ChatGPT, I guess, because that's something that I guess people are aware of right now. Does that scare you? Is that hopeful? Is that really cool to you? Like, are you excited that that exists, or is that kind of concerning? I know that as a student right now, I'm like very weirded out by it because I like made a joke. I said like, oh, I should put that on my resume. Like I can write better than ChatGPT. And someone said, well, can you? I was like, oh my God, can I? Hopefully I should be able to, as like a developed human that has a high school diploma and is in college, maybe I should be able to write better than ChatGPT. But can I? So how do you feel about ChatGPT?
Yeah. I mean, I think I'm sure you can write better than ChatGPT,
Oh,
but
thanks.
like it depends what things you're being asked to write. Like if you're gonna be just writing recipes for every type of cookie under the sun and then writing it as limericks, maybe not. But if you're trying to do anything that people actually want you to do, I'm sure you still have value to add. I think I guess for me, the kind of thing that's been interesting for people in my field with ChatGPT is that so it actually doesn't represent significant progress over what's been happening for the past couple of years, but it's just in the public eye in a particular way, because it's been made available and it has a dialogue interface rather than a purely just generate next words interface. So it's much more easy for people to play with it. But I think right now it's like kind of watching the entire world go through this oh my God moment that I think most people in NLP have been going through slowly over the past 5 years, right? There's been like a lot of not that small, but like now in hindsight looks small, but just like this progress where over the last 5 years we've been being like, oh, they're good. Oh, they're actually better than we thought. Oh, they're actually way better than, oh, they're way better than I thought. And ChatGPT is the latest installment of that. So I don't think I was like, oh my God, this thing exists. It's like we all kind of knew this was coming, or, it's kind of like on the same trajectory that we were on. So from that perspective, I think I probably was less excited or interested than a lot of other people. But right now it's like, I think it's like now it's out in the open where everyone's realizing kind of what the technology does. I wouldn't say it. And so from that, at no point in this trajectory, including with ChatGPT, would I say I'm scared that it exists or upset that it exists. I think I'm actually quite excited to see this because, again, if to the extent that we're interested in having computers that can understand language, the better that they are. It feels like progress, but it also gives us a much more interesting artifact to study, right? So like when I started in grad school, saying, is this system similar to humans or not, was kind of a stupid question to ask because you looked at how the system was behaving and no one would mistake it for a human, right? So you're like, oh, this little program I wrote that spits out, it would do like these stupid paraphrases, right? That you're just like, no one would paraphrase, I can't think of some of the examples, but it's just like weird stuff. So it wasn't a really deep question to ask about connections to human language processing in any, like there were some superficial ways, right? But not in a really deep way. Now I feel like those questions actually have a little bit of heft that they didn't used to have. And that's exciting as a scientist to think about that, right? It's more fun to study something that feels significant and like it's a question that's really worth asking. So I'm excited to see them exist. I'm not scared. I do think that there's risks of things like fake news generation. I think there will have to be some adapting to new technology like this, but I think I'm generally an optimistic person. I feel optimistic.
Okay. Cool. Thanks for saying that. I feel like people are talking about just AI a lot, but especially like teachers worried that their students are using this to cheat and all these kind of things. And I think that that's definitely like a concern, just because it's kind of scary to think about a machine being able to do something as well as humans can do, especially when it's something like language, which we all can do incredibly well.
Right. It's kind of interesting. I mean, I haven't been teaching for that many years, but between teaching and also being a student, I don't know, even before ChatGPT, students are pretty good at BSing an essay and not understanding what they're saying. Like there are classes where I knew full well I was just sliding some terms around and connecting them with enough syntactically correct tissue to pass, and did depressingly well on those, right? Like I was like, I can BS my way through a class that I didn't understand. I know students could. So I like stopped assigning written assignments a while ago because I was like, I can't tell whether the students understand it or not, even before ChatGPT. Like I just don't know whether they know what they're saying or they're just writing stuff, right? So I feel like it's not creating a new problem. It's like exposing an old problem, and maybe like we'll have to be a little more creative with our assessments or something, but maybe it'll be better. Maybe it'll actually incentivize us to have better ways of assessing students' understanding that makes it harder to BS anyway, which is something that should be in everyone's best interest, right? So maybe it's a good thing.
Yeah, absolutely. Thank you so much for listening to Tomato Tomato. I have been your host, as always, Talia Sherman, and that was my interview with Professor Ellie Pavlick from Brown University and Google AI. A huge thank you to Professor Pavlick for coming on the podcast today. It was such a joy to speak with her. If you're interested in reading about her research or in reading more about the classes she teaches and the stuff she does at Google and or at Brown, you can check out the episode description for links related to all that stuff. Please rate, review, follow, subscribe to the podcast if you're feeling snazzy. And if you have any questions, you can email me at tomatotomahto@gmail.com. That is TOMAYTOTOMAHTO podcast@gmail.com. I'll speak to you next time. Bye.